Hi, I am going to discuss about CMOS inverter, complementary metal oxide semiconductor inverter. So inverter function, we know that while giving 0 we need to get output should be 1, while giving 1 output should be 0. So this is the only symbol. Why it is CMOS means there are two complementary transistors they are using. One is NMOS, one is PMOS transistors they are going to use. So that's the reason it is one is complement to another. This is PMOS transistor, transistor, and one more is NMOS transistor they are using to design a transistor. So here two gates are interconnected. This is gate for NMOS, this is the gate for PMOS. Across that we are giving the input signal, and of course supply is required and grounds are required. So here we can take the output P out. Both are complement to each other. This is an PMOS transistor and this is an NMOS transistor. So how you will get the output operation, I will check it. This is an CMOS inverter circuit. We can see this. When the transistor is on condition, when the transistor is off condition. If you take a CMOS, PMOS transistor, if you take, so this is the symbol for PMOS transistor. So this is the symbol for PMOS transistor. You can see this PMOS source, gate and drain, source, gate, drain. And this is an NMOS transistor symbol as we have discussed already in NMOS inverter. So this is an NMOS inverter. It is also having source, gate, drain terminals. So this is an PMOS and this is an NMOS transistors, and when it is on, when we are giving 1, binary input is 1, so it will goes to on condition. Why it is on, I will tell you. When we are giving 1, so the NMOS transistor will goes to off condition, and similarly when we are giving 0, the PMOS will goes to off condition, and it will goes to on condition. So why? Because there are three regions are there for PMOS and NMOS transistors. So here we can see this. When in region 1, when VGS is less than or equal to VT, V threshold. In this case, if the VGS is not sufficient, then VT, V threshold, automatically it is the transistor will goes to cutoff region. So that's the reason it will goes to off condition. And one more condition, VGS minus V threshold is greater than or equal to VDS. Here also it is there is a here in this case the channel is established between source and drain, but there is no sufficient current to flow from source to drain. So this is named as ohmic region. They are named ohmic region. So this is the cutoff region, ohmic region. And third condition, when VGS minus VT is greater than or equal to VDS. If we are given the voltage between drain and source, then the current will flow from source to drain completely, and it is this region is named as saturation region. So that's the reason there are three regions are there for MOS transistor. So that's the reason when we are giving binary 1, so here you can see this, when we are giving binary 1, there is no sufficient VDS, there is a sufficient VGS. That's the reason the PMOS will goes to on condition and NMOS will goes to off condition. While giving 0, the PMOS will goes to off condition, and NMOS will goes to on condition because of insufficient VDS or else sufficient VDS. So that these are the conditions. And coming to the operation, I will check it. I check it here. For CMOS inverter, while giving 1 we need to get 0. How it will get, we will check it. We can see this when we are giving binary 1. So this is an PMOS transistor, so while giving 1, PMOS means it is an PNP. Just assumption there is no sufficient VGS here actually, so it will goes to off condition here, this transistor. And this is an NMOS, means it is an NMOS transistor, NMOS, and this means it is an NPN. So here there is a sufficient VDS and it will goes to on condition, or else you can just assume like this, that is easy for you. 1 means positive and this is positive, just like both are forward bias, it will goes to on condition. We can say this. Now we can say this, it is in off condition already, just assumption only. Actually here there is no sufficient VDS, so just assume it is a 1 positive and this is a negative terminal. 1 to negative means reverse bias, just assumption, so it will goes to off condition. So now we can see this, there is no flow from VDD from here to here, so means you may not get anything here, so just output is 0 because VDD also grounded to through transistor T2. So and this is transistor is named as pull-up transistor, and this is named as, that is, pull-down transistor, because always try to get the output low as possible, and this is try to get the output high as possible. So that's the reason it is named as pull-up transistor as well as, and this is named as pull-down transistor. And this is the first case when you are giving 0. We'll check it when you are giving, I am giving 0 input. Now we can see this when you are giving 0. When you are giving 0, we can see this, just here there is a sufficient energy, sufficient VDS, it will goes to on condition when you are giving 0, or else you can assume like this, just assumption only, 0 to negative. So negative to negative means it is a forward bias, just like it will goes to on condition. And here you can see this 0 to positive, of course it is off condition because of insufficient VDS in this case. So or else you can assume, just assumption, 0 to positive means it is reverse bias, 0 means negative, just assume like that, and it is a P, so means it is a positive, the reverse bias goes to off condition. So now we can see this, it is acted as an open circuit. Now the VDD is flowing through this transistor T1 or NMOS, PMOS transistor will get high as output. So both the conditions are satisfied. While giving 0 we are getting 1, while giving 1 we are getting 0. Thank you.